Let us discuss list comprehension, and we will also discuss dictionary, set, tuple and generator comprehension. So let's start with a simple problem statement. Let's say we have to generate a list having these integers 10, 20, 30 till 100. Basically 10 into I, where I is in the range 1 to 10. So the long solution would be to write a for loop. We initialize a list to empty, and then in a for loop we keep appending one item to it, and it does give us the result. But the quick way would be to use something called list comprehension. List comprehension means that in a list, I write some logic which generates that sequence. So the way I write it is some expression and then for I in the required range. It could be any iterable here. The general structure is some expression for variable in some iterable. So when I do that, basically I get the same result. List comprehension code is very much just a rearrangement of this for loop code. For example, if I copy paste, I take this for loop and I start copying pasting. I first copy paste the element which I'm constructing 10 into I, and then I copy paste this whole thing for I in this. You will notice that I exactly got the content of what I wrote in the square brackets for list comprehension. We will see very soon that you can have if conditions here, or you can have a nested for loop. Here we see some examples of set, dictionary, tuple and generator comprehension. Here we have a set comprehension. So instead of the square brackets, you use the curly braces and you generate a set. Again, you are giving some expression to be generated and then a for logic. You could have a if condition, you could have a nested for loop. Dictionary comprehension, exactly the same structure, curly braces, but instead of one value, you have a pair, key, colon, and then the value. Then the same logic, for loop, if condition, nested for if you like. Tuple comprehension, exactly the same things. You use round bracket instead of square bracket, but you have to give this term tuple. This is a odd thing for tuple comprehension. For list, set, dictionary, we never gave that name. For tuple, we have to give this tuple. If I try it without the tuple, what I get is generator comprehension. Generator comprehension is useful when you have a large range. Let's say you have 1, 1 million. In that case, if you actually store all the values, the size of the sequence will be very large. So generators are tiny objects which just remember where they are, and they have the capability of generating the next when asked. So how do I ask, give me the next? I simply call next result like that. So if I run this code, I get the first three. If I ask more, it will keep giving me more. And it remembers the state and it keeps giving from that point onwards. We will see more details of dictionary, set, tuple, generator as we go forward. Conditional expressions, let's say we want to do the same thing as above, but we want to take only the even numbers. So you can have a if condition. You can say if I% equal to 0. And if you see the manual code for that, it will be something like this. Again, you can see that list comprehension is just a rearrangement. So you can copy the value and then the for loop and then the if condition. And I enclose it in the square brackets and I get the list comprehension. Of course, if you are generating something like 10, 20, 30, 100, it's a arithmetic progression. So you can actually do it just using range. You don't even need a list comprehension. Similarly, if you want this sequence 3, 6, 9, basically the initial value is 3 and the step is 3 and the stop is 300. So you can simply say start at 3, step size is 3 and stop is just a little after the number which we want to include 300, and you get the same result. So for simpler arithmetic progression things, you need not use comprehension, you can simply use range. Let's see nested for loops in a list comprehension. Let's say we want to generate all pairs where x takes the value 1 to 4 and y takes the value 1 to 3. So if you have to do manually, then basically you can have an empty list and you can have a nested for loop and you can keep appending a pair to that list and you will get some such result. Using list comprehension, you can say I want to generate a pair. This is the element in the list, that's a tuple, and I have this loop. for x in range 1 to 5 and y in range 1 to 4. And you see that this shorter code leads to the same result as the longer code had given. And maybe you want only those pairs where x and y are equal, so you can have a if condition. So you get much shorter list where x and y are equal. Let's consider nested list comprehension. For example, we want to play with matrices. Matrices you can understand as a list of lists. So let's say we start with a 0 matrix. We want a 2 cross 3 matrix where everything is 0. So our thought process can be that we want to generate a row, a 0 row for each row number. Basically, for row number in 0 to m minus 1, we want to generate a 0 row. And how does a 0 row look like? A 0 row looks like 0 for column number in range number of columns. This inner comprehension will generate one row, and that row is generated m times, where m is the number of rows. And I have just generated 2 cross 3 0 matrix. Maybe you want to generate a matrix where each element is sum of the indices. So you can have some expression. You can say row number plus column number. In the inner comprehension, you can naturally use the variable of the outer comprehension. Another example, you want to generate an identity matrix. So you want to simply compare row number and column number. If they are equal, give 1, otherwise 0. I simply do a equality check. It gives me true and false. I convert it to int to make it 1 or 0. And here we get a identity matrix. This is an example of tuple comprehension. You are giving tuple as an explicit thing. For generator comprehension, the syntax is almost same as tuple. You don't write the tuple, and when you run this and you print G1, G1 is a generator object. That means it only has the capacity of giving out the next element when asked. It doesn't pre-generate and store all the numbers. That will be very expensive. Generators are very useful if you have a long sequence. You don't want to store all the values. Here I am calling next on the generator 4 times, so I will be getting 4 numbers. It has a state. If I asked further, it will give out values depending on where it was. And how do generators indicate that there is no more data? So let me generate a smaller sequence. So maybe I only generate 3 numbers, and then I ask for 3 numbers. And now when I ask, it has to tell me that there is no more. What it does is it raises an exception called stop iteration. And this mechanism of indicating the end using stop iteration is used by all iterables. So while understanding generators, we have also understood how iterables work. When you have a for loop and you say for I in some iterable, exactly the same thing is happening. The loop is asking the iterable, give me the next. And finally, the iterable says stop iteration, which the for loop catches gracefully and it doesn't show any error. Let's consider dictionary comprehension. So basically, you are generating key colon value, and then you have the same structure for variable in so and so iterable. So let's say we are mapping each number to its square. We give the key and the value is x into x. Let's say we don't want the multiple of 5. So we can have a if condition that if it is not multiple of 5, only then include it. Consider this another example. We have these variables and we want to give them values like 100, 200, 300, 400 in that sequence. So you can have a logic. This time it would be good to do index based looping because I have to compute the value based on the index. The value is 100 into index plus 1. This is the value and the ith element of the var names is the key. Sometimes you are dealing with parallel sequences. Parallel sequences in the sense that we have list of names, we have list of marks, and the index 0 relates. Ram has marks 12, Sham has marks 13, and so on. So now you want to generate a dictionary mapping name to marks. So the long solution would be something like this. You start with the empty dictionary and you keep adding elements to the dictionary. Names I and marks I. That pair you keep adding. You can have a dictionary comprehension like this, names I, colon, marks I, and again you can do a index based for loop and you can generate it. An even shorter solution for such problems would be a utility zip. So when you do zip and you convert it to dict, you exactly get that. What is zip? Zip takes a number of iterables and it zips tuples together based on indices. For example, if you have these sequences, it will give out this tuple, then this tuple, then this tuple index 2, then this tuple, and then it will stop because this sequence has exhausted. So zip stops at the shortest sequence. Till that point, it keeps clubbing or zipping together those elements and it returns those tuples. If we convert it to list, essentially it's returning these tuples. One way to construct a dictionary is to give it a tuples and it takes the first as the key and second as the value. Let's extend it. Let's say we have names, grades, and heights. Ram has grade A equivalent to marks and height 176 and so on. Okay, so these are again parallel sequences, and if you zip, you can do like that. For each person, you want to store a tuple having the grade and height. So you can use a dictionary comprehension like this, that map name to grade comma height, where name, grade, height are elements in the output of this zip. This zip returns tuples. And using tuple unpacking, I captured them in 3 variables and I construct a dictionary element, name mapping to this tuple, grade and height. So you can see it is much simpler than index-based looping, because in index-based looping you would have to explicitly take care of taking the minimum of the 3 lengths. So zip does it for us and we don't have to deal with the indexing. Set comprehension is quite simple. Let's say we have to generate variables names var1, var2, var10. So we can simply generate that string name. I do var and I convert the integer to string so that I can concatenate and I can have a loop. Again, the syntax is expression and then some for loop, maybe if condition, maybe a nested for loop. So that was about comprehension. If you have any questions, please put them in the comments below and we'll discuss them.